Okay, for this video, we'll be going through 2021 paper 2. There are only a few more papers left, so hopefully you have been doing your paper diligently, and also to add up the marks and to find out which chapter you are still weak in, because there's only 2022, 23, and then the specimen paper, and then that's it. Okay, hopefully you are starting to see the upward trend in your marks. Okay, let's start with section A. Now, complete these sentences about scalar and vectors quantity. So by now, you will know that vector has direction and magnitude, whereas for scalar, it only has magnitude. So what has magnitude only? So scalar and vector has both magnitude and direction. So basically, filling in the blanks correctly, you get your 1 mark. Now, then they ask us to state which quantity is a scalar using S and which one is a vector using V. So you have to follow the instructions and put S and V. Okay, so acceleration vector, density scalar, force vector, speed is scalar. Okay, so the vector for speed is actually velocity. Okay, hopefully you have made a list of scalar and vector quantities. Pressure will be scalar. Vector moments. Okay. Then we also have distance, that is not here. Time. Distance vector is actually displacement. Okay. So for displacement, it has direction and magnitude. Okay, so hopefully you have already all this list of scalar and vector. So this is, I think this appears in one of our tutorials as well, similar questions. Okay, so this is a moment question, right? Because that you see there are actually a lot of pivots here. Okay. So the rods and threads have negligible weight. That means they don't add on to any forces. The rods are horizontal and equilibrium. That means we can apply principle of moments. Now the tension in thread T, where's thread T? Is 1.1. Okay. That means the total downward force for the peak, shape, and count must be equal and opposite to 1.1 Newton. So that means this is, the peak has a weight of 0.5 newtons. Okay, calculate the weight of the toy peak, so it's 0.5 newton. Okay, the graduations on rod R are equally spaced. Where's rod R? Rod R is here. So all these are the graduations. Okay, so they are equally spaced. So we take note that there's 1, 2, 3, 4, 5, 6 graduations. All right. The weight of the toy lion is 0.4 and that of the toy elephant is 0.9. Yes, so that's written there. Okay, by taking moments about point P, calculate the weight of the toy kangaroo. So let us do our moment 6 steps. So first step, we see that the pivot is over here. Okay, secondly, we need to know how many forces are there. So there's a weight of kangaroo. I call it WK. So there's one force, second force, and third force. Sorry, I'm doing step 2. Step 1 is the pivot. Where's the pivot? Step 2 is number of forces. Step 3 is the most difficult, which is to find out the perpendicular distance of each force to the pivot. So now they actually don't give us the length, they actually give us graduation. So we have to take take the reference from pivot P, right, which is over here. So we see that the lion has 4 graduations. So times 4. For the kangaroo, there's 1 graduation. For the elephant, it has 2 graduations, right? So basically, it is 2 graduations away from the pivot. For lion is 4, for kangaroo is 1. So this is our step 3. Okay, I hope you understand the circle numbers. What do they mean? It means a step. Now step 4, which is calculation of moment. So we take 0.4 multiplied by the graduation. Okay, so it doesn't matter if we do not know the length of the graduations, because in the end, through the principle of moments equation, we can work that out. Okay, so here will be 1.6 Newton with the graduation, maybe I put G lah. Okay, so for this will be 1 WK and then G, and for the elephant it is 1.8 Newton, and with the graduation. Okay, so I put graduation because they didn't give us the length. If we know the length, then we can substitute in. Okay, or you can just put one graduation as 1 cm. That works as well. Step 5 is to find out the direction of the moment. For this will be anti-clockwise. For the kangaroo's moment will also be anti-clockwise. For the elephant, it is clockwise. So step number 6, we can apply principle of moment. So 1.6 Newton G. Okay, the G again is a dummy letter that I just use. 1 WK and G equals to 1.8 NG. Okay, so you find that the NG can actually cancel out. Okay, because they exist on both sides lah. So 1.6 plus WK equals to 1.8. Therefore, WK will be 1.8 multiplied by minus 1.6 equals to 0.20 Newton. Okay, so that's the answer, 0.20 Newton. Okay, let me just double check on the answer. Okay, so yeah, something like this. Okay, let's go back to the question. What else do they ask? Oh, that's all. Okay, now question 3, a squirrel picks up a nut from the ground. It climbs to the top of a fence where it eats the nuts. Okay, so the combined mass is 450 grams. Combined mass of squirrel and nut. So 450 grams, I know this may be GPE or something, so I just change the mass to be equals to 0.45 kg, just in case, yeah. Okay, when the squirrel climbs to the top, the center of gravity of the squirrel and nut rises by 2 meters. That means this is the height. Calculate the gravitational potential energy gained by the squirrel and nut when the squirrel climbs to the top. So G is 10 Newton per kg. So GPE, this is simple, equals to mgh. But what will some students forget to do? They will forget to change the mass to 0.45 kg. Okay, so this one will be 0.9 joules. Alright, let me check the answer. 9 joules. Okay, next, the total chemical energy contained in the nut is 15 kilojoules, which is 15000 joules. Okay, so take note of the prefixes. Now, if all of the energy contained in the nut is converted to an increase in GPE, calculate how high it can climb with the nut with this amount of energy. So actually, this one mark very simple, 15000 joules divided by 9. Okay, and I need to multiply by 2, right? Because 9 joules, I can climb 2 meters. Okay, let me check the answer. So it presents it a little bit differently, but let me just check if my calculation is correct. 15,000 15000 divided by 9 times 2. Okay, so I also have this answer of 3333 recurring, right? So this is actually 3330 meters. Okay, because in 3SF. Why do I need to multiply by times 2 by 2? Because every 9 joules require every 2 meters require 9 joules. Okay, so yeah. Okay, question 4, a shell of mass 36 kg, this is my M, is propelled along the barrel of a gun by explosive charge. So this is the distance, and I take note that all of these are already in SI unit. So this is my D, so this is my mass again. The shell undergoes constant acceleration, constant. It reaches a top speed, maximum speed at the end of the barrel of 870. So this is V. Initially, the speed must be U in a time of 0.013 seconds. Distance traveled by the shell while it's accelerating constantly is 5.7 meters. Calculate acceleration. A equals to V minus U over T. So you see that by annotating everything here, excuse me, you can easily get your answer. So please annotate the numbers. Let them have an identity so that you know how to substitute into the formula. So let's look at the answer. Okay, so A equals to V minus U over T, so I get 6.7 times 10 to the power of 4. Okay, so remember to change it to 3 or 2 SF. Now calculate the resultant force on the shell. So you take the mass multiplied by the acceleration that you have gotten. Then you will get 2.4 times 10 to the power of 6. You don't have to leave it in standard form. You can leave it this way. 2SF is also okay. So you should be getting this 4 marks. Now, what's the work done on the shell? Work done is equals to force times distance moved in the direction of the force. So you'll get this. So actually, if you really understand what the letters and the numbers mean, by giving them their identity, you put into the formula correctly, you should be able to score very well. Okay, so please do that. Okay, then next question is on this. 3 copper cans, so they are all made of metal. Right, as you're reading, write down all these annotations. A, B, and C are shown equal volumes of hot water, same initial temperature. Okay, but we see that A is painted black, so it is a good emitter and absorber. But because inside is hot water and surrounding definitely is colder, so it will be emitting thermal energy. So later we'll just be talking about emitting. Then we have copper painted black, and C, when I first look at it, I see, how is it that they contain equal volume? Because the base area, okay, or the volume of the container is smaller than A and B, right? That's why the water level is higher by almost half, I see. And they're all painted black. Now, A and C have lids, B has no lid. So what's the function of the lid? Is to prevent thermal energy loss by evaporation and also by convection current, right? So some of you would like to say that it traps heat. Not really accurate. They won't really accept this. Okay, don't say it traps heat. B has a smaller diameter. Now for each can, the temperature is measured every minute. Okay, not seconds. As the water cools and the graph is drawn shows that what is obtained for can A. So for can B, do you think that it will lose thermal energy faster? Okay, so they want us to sketch the line obtained for can B and then to explain. So because can B doesn't have a lid, okay, so the amount of thermal energy emitted will be much higher. Okay, so you cannot be drawing a straight line. For those of you who are marking, don't draw a straight line, and it must look like a curve. Okay, because as the temperature difference between the hot water and the surrounding gets smaller, temperature difference decreases. The rate of thermal energy loss will also decrease. Okay, so that's why it is from steep to gentle. It cannot be a linear. Okay, then you need to label it as B. Okay, now explain your answer. Water in can be cools faster as it has no lid. Convection, so this is convection, not convention. Convection of the air above the water can take place, removing thermal energy. Don't use heat. Thermal energy. Okay, try not to use heat at a faster rate. Heat as an action, as a verb is okay, but heat as a noun, okay, is not okay. Use thermal energy. There is also evaporation of water, just like what I talked about it. So every time you see a lid in thermal energy question, you must know this too. Okay, so evaporation of water from can be also causes faster rate of heat loss. Again, use thermal energy. Now, state why the temperature of the water in can C decreases more rapidly than the temperature of the water in can A. right? So basically water in can C has a larger surface area in contact with the copper can. Now, do you remember A and C? They actually both have lead, so we cannot use the lead reasoning here. But however, C has a smaller diameter. Okay, so what does it mean? Okay, C, water in can C has a larger surface area in contact with the copper can, right? So this is the amount of area that's in contact. But for C, you can see that it's larger, even though the diameter is smaller, but over here at the side, it really has a larger contact area. Okay, so larger surface area in contact is important. Copper is a much better conductor of heat compared to air, therefore water in can C cools faster. So this is where the copper comes in, because copper is a metal, so it's a conductor of heat. So I often have students say that copper is a good absorber or emitter. It's a good absorber, example, or emitter. No, this is false. Okay, because for copper it is a metal, you talk about conduction. On the other hand, I also have people say that black is a good conductor or poor conductor or whatever. Okay, so black does not go with conduction, it goes with radiation. Okay, then how about convection? Convection is when you see fluids. So it's either gas or liquid. Okay, so take note, when we are talking about conduction, we can use particles. We can talk about it. Okay, but for convection, do not talk about particles. Talk about the fluid as a whole, right? The volume of air increase, example. Do not say volume of air particles increase, because that is not correct. Okay, question 6. Here's some music, so probably it's a sound wave. Question: a signal is sent from the computer hard drive to a loudspeaker by means of an EM wave of frequency 2.4 gigahertz. Giga, by now you should know, is 10 to the power of 9. So frequency's unit is hertz. The loudspeaker converts a signal into a sound wave that travels to the girl's ear as illustrated. Calculate the wavelength of the EM wave. Now, the speed of EM wave in air, they give us 3 times 10 to the power of 8. I think previous year they never give us, right? Just 2020 they didn't give us. So nonetheless, it is good to memorize. For light, for EM wave, for radio wave in air or in vacuum is about this value. So now we have our V, we have our F. They want us to calculate the wavelength lambda. Okay, so remember to change your giga into 10 to the power of 9. So you'll get 0.13 meters. Okay, now describe the motion of the particles in a sound wave. So this is only 1 mark. So they want us to describe the motion. Okay, we have already seen similar type of questions in previous years. So the air particles vibrate parallel to the direction of travel of the sound wave. So the keyword here is parallel. Okay, now there is no such thing as sound particles, so do not say sound particles. Okay, whichever medium that the sound waves travel in, you use that medium's particle. Okay, you use the medium's particle. Okay, it contains statements about EM waves and sound waves. Some are true, some are false. Use T to indicate true and F to indicate false. Speed of sound in vacuum is approximately 330. This is false because sound cannot travel through vacuum. Okay, so this is the answer. False, sound needs a medium to propagate, to travel through. Light waves travel at different speeds in solids than in gases. True, faster in gases, slower in solid. This is for light, yeah. For sound, it is opposite. Speed of EM waves in air is greater than the speed of sound in air. True. In an EM wave, the vibrations are perpendicular because EM wave, they are transverse. Okay, so this is true. Okay, for sound wave, it is longitudinal parallel. Sound waves travel at the same speed in liquids as they do in solid. This is false. Okay, it's for sound travels faster in solids than in liquids. Do you know the explanation? So this one you have to say the solid particles are closer together, then easier to transfer the thermal to pass on the energy by collision. Okay, they are closer. Okay. Okay, question 7. Battery powered electric motor provides the energy for an electric scooter. So it gives some of the specification. The top speed along a horizontal path is 1.6 meter per second. Maximum range starting with fully charged and traveling at top speed. So 24 km. Charging current for battery is 8 ampere. So this is my current. Okay, so this is distance and this is speed. Okay. Calculate the time for a fully charged battery to be completely discharged when the scooter travels at top speed. So the time taken is this distance over the speed. So you'll get 15,000 seconds. Okay. Now, common error due to prefix. You didn't change your km to meter. So basically, km and meter, they don't tally what, right? So you need to change one to the other. Okay, so sometimes students get 15 seconds, then they like, wow, this electric scooter I need to charge every 15 seconds. Okay, the charge provided by the charger to the battery in 2 hours. So 2 hours again, this is my T, but I take it that it must be in seconds. Okay, so it's 7200 seconds. Then we apply this formula because charge is Q equals to IT. Okay, so I have my time over here, right? Then I can find my charge using the current from here. So 8 ampere, we can just take it as it is. So 58,000. So by right, this should be easy 4 marks, yeah? Okay, then we come to a DC circuit. We see that they are connected in parallel. So a kettle of resistance 24 ohm, toaster is 28 ohm, and coffee maker resistance of 170 ohm. They are connected in parallel. So the V is this, R. Okay, so I call this RK, RT, and RC. Okay, so calculate the effective resistance, easy. So remember to flip. Okay, so you do 1 over 24 plus 1 over 28 plus 1 over 170 equals to 1 over resistors in parallel, or effective resistance, REFF. Then you remember to flip your answer. So it should be 12 ohms. Okay, so either 2 or 3 SF is okay. Now, the maximum safe current from the 230 volt supply is 28. That means if I have 28 ampere, it is safe. So this is in parallel. Therefore, the IK, current through kettle, current through the toaster, and current through the coffee maker should be equals to 28 ampere because of sum in parallel. In parallel, the current is the sum. Okay, so let's see how we can use this. Show whether the kettle, the toaster, and the coffee maker may all be used safely at the same time. When all is used at the same time, the effective resistance is 12. Okay, so we have 230 volts, and if it's divided by the total resistance, we get 19 ampere. So you see, since the total current drawn from the supply is below the maximum safe current, all three may be used safely at the same time, right? This is what I'll be drawing if all three are used. While they tell me that maximum safe current from the supply is 28. So yes, okay. Kettle, toaster, and coffee maker all switch on for the same length of time. Which one uses the most energy? Explain your answer. So why kettle, right? Kettle having the smallest resistance. Potential difference across all three are the same in parallel. Potential difference is the same. So using power, P equals to V squared over R. Do you know how to get this formula? This is the most basic, P equals to IV. Okay, but that means we need to know I, and because V is already given, we have to sort of find I. So some students may find it quite tedious. So why don't I use V equals IR, and I can transform this into P equals to I square R. right? Because V is equals to IR, I substitute my V as IR, so I'll get I square R. But then again, I need to know my current, although I have my resistance. So then the last form will be P equals to V square over R. How do I get V square over R? By transforming your V equals to IR to I equals to V over R. So now I substitute I as V over R. So in the end, I'll get V square over R. Please try it for yourself. Even though you may not want to use all, you want to calculate using current, it's still fine. But it is good that you know that all three formulas exist, although they'll all give the same answer. But why does the third formula gets used here? Because I know the V, right, is given as 230 volts. I know the resistance of each individual component or appliances. So V square over R will quickly give me the value of P. Okay, so with this formula, you can actually use it in your answer. So I say again, in physics, right, a lot of times when they ask you to explain, you dump in the formula, it will help. It will help. Okay, question 9. A reed switch is one type of switch for an electrical circuit. The reed switch contains two metal strips that are in contact unless a magnet is brought close to them, as illustrated. So they are in contact. Okay, they are in contact. The contacts are close, but when I have a magnet close to it, they will separate. So the two metal strips are made of a magnetic material. So what are the magnetic materials in our syllabus? We have iron, cobalt. Okay, so cobalt is not to be confused with copper, nickel, and steel. Okay, so these are the magnetic materials. But when we are talking about soft and hard magnetic material, iron is a soft magnetic material, steel is a hard magnetic material. Soft meaning easy to magnetize and easy to demagnetize. For hard magnetic material, it's hard to magnetize and hard to demagnetize. Suggest why the magnet causes a strip to lose contact. It's because they are magnetic material, so now I have magnets near it. I will cause them to be induced magnet. So let's read on. Both ends of the metal strips are being induced with the same magnetic poles in the presence of the magnet. So if here is north, here will be south. Correct? Yeah. So here will be south as well. So here will be north, here will be north. Okay? So, sorry, I just want to clarify. If I have a north and south, okay, and if I have a magnetic material here, so as you know, north, magnetic field lines are going into, okay, coming out. For south, is going in, okay, into the south, coming out from the north. So here, if it's going into south, then here must be an induced north pole. Okay, so if north is here, here must be south, here must be south. Let me double check the answer. They never say. Okay, so anyway, another thing is they may test you on drawing of field lines. So remember, the magnetic field lines do not touch each other, cannot cross each other, and they must have the correct direction. Comes out from north, enters the south. And if I have a compass, the compass will be pointing in the direction of the magnetic field lines. Okay, so come back to the explanation. Both ends are being induced with the same magnetic pole. Since like poles repel, this is a concept that you need to explicitly state. Both strips will push each other apart and break contact. Now, suggest why the strips do not close when the magnet is removed if the strips are made of steel. So you see, we can actually sort of predict the kind of questions that they will ask. Just now I was talking about magnetic material, iron, and then steel, right? Then steel is hard to magnetize and hard to demagnetize. So now they're asking for this concept. Steel is a hard magnetic material used to make permanent magnet. They will not demagnetize easily, or they will not be magnetized easily. Okay, you see, they do not close when the magnet is removed, right? So, like now, let's say it is made of steel already. It's made of steel, right? So if I have my magnet here, although it will be hard to magnetize, eventually they will still open. But after that, when I remove the magnet, the strips will still be open. They will still be having the same south pole and north pole because they are hard to demagnetize. So they will continue to repel each other even in the absence of the magnet. So 4 marks like that. Question 10. Attaches a piece of paper to a notice board using a thumbtack with a force of 18 Newton. So the point of thumbtack area is this. One thing to take note that this area, it is in cm square. Now the head of the thumbtack area is also this, is 6.4 times 10 to the power minus 1 cm square. So this has a larger area, this has a smaller area. So I think they'll be asking for pressure lah. So calculate the pressure exerted by the thumbtack on the paper. On the paper, it is having this area. So we need to use the area that is in contact and not the area of the head of thumbtack. So we get 7500 Newton per cm square. You see, they are quite kind. They never expect us to change it to Pascal or Newton per meter square. If not, then we have to convert the area to meter square. Okay, so we have 7500. Explain why the thumbtack pierces the paper and the notice board but does not pierce the girl's thumb. So you need to know this. The girl exerts the same force on the thumbtack head and also on this part of contact. Okay, it's same force of 18 Newton, but it is now distributed across a much larger area of the girl's thumb, right? So the force per unit area, hence pressure on the thumb, is much smaller compared to the pressure at the point on the paper. So if let's say now this is the notice board and the girl uses a pin like that, okay, uses a pin, will her thumb be pierced? Yes, of course, because now the contact area is the same, is equal and very small. So the pressure equals to force over area. The area is increased by so much, same force, the pressure will increase. So she will also pierce her thumb as well. Okay. So an object is placed 10 cm from a thin converging lens. Not sure how much of this lens will be asked, but let's just try. So where is the lens? The lens is here. So this is the lens. Okay. Lens, just to recall some terms that you need to use. This is the principal axis. Okay, it's the center line that passes through the lens, and this point here is called the optical center, C. This is our focal point, and the distance between focal point and the C, center of the lens, is called small letter f, focal length. Okay, so if object is on the left hand side of the lens, the image, if it's found on the right hand side, opposite side, okay, will be inverted and real. Okay, so I asked you all to memorize using infrared, right? Because just nice, they start off with I and R. So it must definitely be inverted and real. Inverted and real. What if the image, which is now here, is found on the same side as object, same side? Then it is UV. Okay, it must be upright and virtual. So besides upright, virtual, and inverted real, another thing that they like to ask is whether is it bigger or smaller. So is it magnified? In this case, you see that it is larger, so it's magnified. What if it's smaller? Smaller is called diminished. Don't say things like smaller, tinier, okay? Magnified or diminished. So we see that the object is on the left hand side, image is also on the left hand side, therefore image must be upright and virtual, and we see from the size drawn, it is magnified. Okay, so draw the two light rays just to I'm not sure how much they will ask, right? But the three light rays that we need to know is one that passes through the optical center. This is the first one. Then the other one is it will be parallel to principal axis. Once it touches the lens, it will go and cut F. And then you see that these two light rays, right, actually will never ever meet. So our brain will think that, oh, actually there is an image here, right? Because there must be a meeting point. So that's where it draw backwards using dotted lines, because it's imaginary, to create an image that is virtual and also upright. Can? So use the rays you have drawn to determine the focal length of the lens. Focal length will be here, so you have to use the scale. Okay, so not sure how much of this will be asked in your new syllabus. Okay, let's go to question 12. A lighting decoration consists of a transparent colored disc that's made to spin using an electric motor. Light from a lamp passes through the disc into a bundle of optical fibers. So optical fibers not really in our syllabus. Okay, so the motor is 1.5 watts, lamp is 9.5 watts. Okay, these are the power. Okay, power of motor and power of lamp. So on figure 12.1, draw electrical connection so that lamp and the motor are connected in parallel. Okay, in parallel, that means they cannot be joined over here, cannot, right? They must both be connected to the 12 volt supply. So the red color one, you see for this one, it is connected to 12 volts for the motor, and the other side they use green color, they connect to the other end. For the lamp, one side is red, the other side is green, and now they are connected in parallel. They may not always like have it drawn nicely like that, like in the previous question. They may not be, okay, but as long as they share one connection and the other connection, then it should be parallel. So just one reason why connecting motor and lamp in parallel is an advantage. So this one you should know, very simple. The lamp has a power of 9.5, so PL. Motor has power of 1.5 watts. Calculate the current in the 12 volt supply when both are working. So this one looks quite similar to the previous DC circuit question. So what's the total power delivered? Every second is 11 joules per second. Okay, you just add up, that is the power because both are working. P equals I over V. Sorry, I equals to P over V, or I memorize as P equals I over V. So since I have P, I have V, I can find my I, so 0.92. Now a device to change the voltage from 3230 to 12 volts. Okay, so there are no energy losses. So this is actually a transformer lah, this device. So by right it's not in your syllabus, but they give us some background information so we can actually attempt to use it. So this is transformer, it changes the input voltage 230 to 12 volts because 12 volts is what we wanted to be used here, right? 12 volt supply. Okay. So use your knowledge of electrical energy transfer to explain why the current in the input of the device is less than the current. Because there's no energy losses, input power must be equals to output power. This is in line with the principle of conservation of energy. Alright. So because P 230 volts must be equals to P 12 volts, right? So I 230 times V 230 must be equals to I 12 volts and V 12 volts, correct? Because this is then our output and this is our input. So all this can be equated together because there's no energy loss as mentioned in the question. Okay, so when the input voltage is greater, now this is 230, right? The current will be smaller, right? So similarly on this side, the voltage is small, this one is small, so the current must be big. Okay, so therefore the input current will be less than the output current. Okay, so this is optical fiber, not in our syllabus, so you should minus 2 marks and 3 marks. Okay, 2 and 3 marks. So your total for your section A, you should minus off 5 marks. Okay, now we go to question 13. Okay. So actually for section A, no deduction of mark. Section B, if you try question A, only 5 marks are tested. Okay, so now we go through the rest of section B. Okay, so for section B, a spacecraft of mass 350 kg is approaching a planet. So this is our mass. Then the variation with time of the speed. So this is a speed time graph. As it travels through part of the atmosphere is shown in figure 13.1. So it's labeled A, B, C, and D. So at point A, the spacecraft enters the atmosphere. So it starts to experience air resistance. So the speed that it enters is 5400 meter per second. At B, a parachute is open to reduce the speed. How? Because the parachute increases the surface area or area in contact with the air. So this increases your air resistance. Okay, so name the two forces acting on the spacecraft between A and B. So it's either weight or gravitational force and air resistance. With reference to forces acting on the spacecraft, explain why the speed increases between A and B. Okay, so between at A, remember it just enters the atmosphere. Okay, between A and B, there's a resultant force directed towards the planet as the weight is greater than the opposing air resistance. Why is it greater? So the air resistance is just starting to be built up. What causes air resistance to increase? I've highlighted one factor here, which is when I increase surface area in contact, the air resistance will increase. The other one is as speed increases, air resistance will increase. Air resistance will increase. Okay, so now as there is a resultant force, because the initial air resistance wasn't a lot or very little, so there's an acceleration. Okay, so the spacecraft will accelerate in the direction of the resultant force, therefore the speed will increase. Now part B, forces acting on the spacecraft changes its motion. Between B and C, the speed decreases and then it travels at constant speed to point D. Let's take a look. Between B and C, the speed decreases, and C and D, from C to D, it travels at constant speed. Okay, so explain in terms of Newton's law why the motion of the spacecraft changes between B and D. So we have to separate into B and C, and then C and D. So what happens at B? The parachute is deployed. The parachute is deployed. Okay, so what's the effect of deploying a parachute? It increases surface area in contact, and this increases our air resistance. So let me draw a free body diagram. Okay, so basically this is a spacecraft. The air resistance is now larger than the weight, right? Because I deploy my parachute. So what's the direction of the resultant force? Direction of resultant force is upwards. But what is the motion? The motion is downwards, right? The motion is downwards. So now my F net is opposite to the motion. Therefore, it will undergo deceleration. It will slow down, right? So let's take a look. When the parachute opens, the air resistance becomes larger than weight. So use this to understand. This results in an air resultant force that acts in the opposite direction to motion, using this drawing of free body diagram. So by Newton's second law, because they want us to explain in terms of Newton's law, the spacecraft will accelerate in the direction of the resultant force, which means it will decelerate. So when it decelerates, the spacecraft will decrease in speed. So just now we say as speed increases, air resistance decreases. But now, opposite happens. As speed decreases, air resistance also decreases. This is important. This continues until air resistance balances with weight, right? So my air resistance will continue to decrease, but my weight will remain the same. So it will decrease until it is equal and opposite to weight, so that the resultant force is 0. Then by Newton's first law, the spacecraft will continue to travel at constant speed. So this question is tough, but manageable. So I would advise you to actually read through this answer again. Okay. Question C, with reference to 13.1, describe the energy conversion that occurs as the spacecraft moves from point A to B. Point A to B, GPE, gravitational potential energy, spell it out, converts to kinetic energy of spacecraft and some thermal energy, which is transferred to the internal store of the surrounding. So what is this due to? Work done against air resistance. From C to D, we know that the speed is constant, right? So therefore, you cannot say that there is conversion to KE. There is no conversion to KE. So the gravitational potential energy converts to thermal energy or internal energy of the surrounding. So we cannot use convert, you must use transfer, okay? This is before the syllabus change, transfers to internal energy of the surrounding and also the spacecraft. Okay, so the spacecraft will touch, when you touch it, it feels hot. Now the spacecraft then land on the surface. The weight on the surface of the planet is 1400 Newton. State what is meant by term gravitational field. So it's a region of space in which a mass experiences a gravitational force. So in your course of study, there's also electric field. So it's a region of space in which a charged particle experiences an electric force. Okay, so learn to adapt and change the keywords, and you don't have to memorize so much. The other one is magnetic field. So instead of charge or mass, you now use a magnetic material. Okay, experiences a magnetic force. Okay, it must be magnetic material and not just magnet. Okay, so what is another definition they may ask? They may ask for gravitational field strength. Okay, so this can be found in your notes as well, gravitational field strength. They may ask for what is mass, what is weight, definition of mass and weight. Okay, so calculate the gravitational field strength on the surface of the planet. So they gave us the mass of the spacecraft, right? Yeah, 350. So sometimes this thing may be missed out by students because it's presented at the initial part of it. So that's why annotating is important, so that you know to use the mass and where to find the mass. Okay, so this is for question 13. So you might really want to take a look at this just before the exam. Okay, question 14, I think last question, shows the variation in temperature with the volume. So the mass of the lead is 150 grams, so take note it's in grams. But because the volume is in cm cube, so I don't worry so much, because later if they ask for density, it will be mass per volume. So it's gram per cm cube, so it's fine. The lead melts at 327 degrees, so it is, so this is 320, 340, 36, 380. So 327 is somewhere here, right? Somewhere here. Okay. Use figure 14.1 to state what happens to the density of the lead when it changes from a solid to a liquid. We need to use figure 14.1. So from 14.1, the volume increases, right? The volume actually increases from 13.2 to 14, 13.2 to 14. Okay, since density is mass per unit volume and mass is a constant, density will decrease using density per is equal to mass per unit volume. So for the liquid lead at 327 degrees, state is volume, so it's 14 cm cube. Calculate the density, the mass is 150 gram. So we just leave it in gram per cm cube because they never ask us to calculate density and leave your answer in SI unit. If it's in SI unit, then it is kg per meter cube. Okay, by the way, kg per meter cube to gram per cm cube, you divide by 1000. Okay, so gram per cm cube to kg per meter cube, you times 1000. Okay, the spacing of the particles of lead changes when the lead melts. They never say the lead particles increase in size. It's the spacing. State the change in the average spacing. Average spacing increases when lead becomes a liquid, right? Because the spacing between liquid particles are further apart. Explain why the lead must be given thermal energy when it melts, even though temperature does not change while it is melting. So this one is a classic textbook question. Thermal energy goes to increasing the molecular potential energy. Now, whenever we talk about the particles and molecules, we do not use store. I think I mentioned this in my previous videos already. It's only when we are talking about the object, then we use store. So it is used to increase the molecular potential energy to weaken the bonds during melting. So there's no gain in molecular kinetic energy, so temperature does not increase. You need these 2 points. Okay. Overall, the total internal energy, which consists of the potential energy and kinetic energy, this total internal energy increases. Now, when the lead has melted, it can be poured into a mold. Explain why in terms of the kinetic model, why the lead can be poured when it's a liquid but not. I think we saw this question somewhat in previous years. You can look back. So the particles of solid lead are bounded by very strong forces of attraction. Therefore, they are closely packed, held in place in an orderly manner, and can only vibrate about fixed position. Therefore, it has fixed shape and it is unable to pour into a mold. Then you need to compare. On the other hand, particles of liquid lead are less strongly bounded, so their forces of attraction are weaker. They are slightly further apart and can slide freely within the liquid. So this is the main thing. So it allows the liquid particles or the liquid lead to take up the shape of the mold. Okay, so comment here, they did not make reference to the forces involved.